Okay, this is your practice quiz for Unit 6B, which is sections 8.4 and 8.6 out of your book. I'm going to try to talk quickly so it's not very long, but please keep in mind that you can slow down and speed up the in YouTube when you watch this. Okay, so simplify each expression, state the restrictions on the variable. All right, so we have, there is no adding or subtracting in here, so I am just looking at the factors, and I look at 12 over 48. If you don't know it, use the fraction button on your calculator. 12 goes into 48 4 times. We've talked about these variables. I have x's on the top and the bottom. I have more on the bottom, so that means that I'm going to end up with x's on the bottom. How many more on the bottom do I have? I have 2. And of course, all of that's on the bottom, so I have to have a 1 on the top. All right, the restrictions on my variable, again, if there are no pluses or minus in this denominator, then that variable just cannot be 0, because that's what makes the denominator 0. Okay, on to the next one. 4x minus 28. Okay, all of these, y'all, when you're looking at them, if there's any plus or minus in them involved, to start off the problem, you got to factor. There's no, I'm not adding or subtracting here, I'm just simplifying this expression. So I'm going to factor this as the difference of two squares, starts with a number. So my factoring starts with a number. I'm going to have 7 minus x, 7 plus x, and on top there's a common 4, which gives me x minus 7. These two we have talked about. You will see it on your quiz. Okay, they are opposites of each other. So if you want to simplify by canceling from the top and the bottom, you have to put a negative sign either in front or on top. So this is going to give me negative 4 over 7 plus x. If you have any questions about anything when you're watching this or later, then you can come see me before school. I get there early in the morning, or you can email me. Okay, when you're trying to find your restrictions here, okay, you cannot rely solely on the answer. You need to look back at the original problem. And mostly, of course, in that factored form. So if 7 minus x and 7 plus x, if you set each of those equal to 0, you will find out that when x is 7 or negative 7, I'm going to have a problem. So those are the restricted, that I'm not look right. Those are the restrictions that we have. X cannot be plus or minus 7. Okay. Again, I got a factor. So I have I got a little more room here, so I'm going to go 5 times x minus 2 on the top, and the bottom is x minus 2 quantity squared, because that's a PST. And whether you know that or not, if you write out x minus 2, you're going to get the same thing. I have the same factor on the top and the bottom. I have 2 on the bottom and 1 on the top, so it will simplify to 5 over x minus 2. What can x not be? Okay, that's the same factor twice. X cannot be equal to 2. Again, you're just setting that factor equal to 0 and solving. Okay, let's go with, now this time we have operations up top. Okay, each expression that I gave you was just all by itself. There was no plus or minus, multiplying or dividing involved. So now we have to go pay attention to what operation is going on. We're still going to state the restrictions. So this is division, and when we divide with fractions, we keep, change, and flip. So I'm going to keep this the same, change my division to multiplication, and then I flip this one. Now, the other thing, unless you think these two you can cancel because you have an x on the top and the bottom, y'all pay attention. You only cancel if this looks exactly like that, and they're not exactly the same. This one has a negative exponent. So what do we do with that is we remember that if I want to make it positive, I have to put it in the opposite place, which would be the numerator. If it was negative in the top, I can make it positive and put it in the denominator. So now, when I look at my x's, I actually have 6 up top. Let me get that out of the way there. Just look at that operation. Okay, so I have x to the 6th on top. Where do I have more y's? I have more y's on the bottom. How many more do I have? 1. So it's going to be x to the 6th over y. Now, remember we've talked about when you divide, you have to look at both the numerator and the denominator. of the second part that you're dividing. So this tells me that x cannot be 0 and y cannot be 0. All right, next we have 3x minus 9. So I have two things that I am multiplying together. I need to factor, okay? And please don't anybody do this to me, but remember, we cannot get rid of those two things because each of those is a term. So before you start canceling, ask yourself, is it a term or is it a factor? And if it's a term, you cannot factor it. You cannot cancel it. Okay, so 3 times x minus 9 has a common 3. X minus 9x, x squared minus 9x plus 20 is going to become x minus 5, x minus 4. And on top here is a PST of x minus 4 squared, and down here is x minus 3. Now, it's an easy thing to check, y'all, when you do something like this right here. 5 times 4 is 20. Just check that, okay? 5 times 4 is 20, and negative 5, negative 4, positive 20. And then the other term is minus 5x minus 4x, and that gives me my minus 9x. So I don't have parentheses around here. Some people think you can't cancel that, but that is the whole denominator, so it is a factor in and of itself. So yes, these do cancel. I have an x minus 4 on the top, and I have 2 on bottom, but now I have 1 left, and nothing else simplifies. So that leaves 3 times x minus 4 on top and x minus 5 on the bottom. Now, what can x... Oh, goodness, I didn't know how that happened. Let's go make sure it stays. Seriously? Golly. Okay. What can x not be? Okay, so I'm looking at this bottom, but here it is in factored form. So that means I'm going to have x cannot be 3, 4, or 5. The order that you write those in does not matter. Okay? Moving down to number 6. All right, this is a division problem, so we're paying attention to that to begin with. So when I rewrite it and I start factoring, I'm going to flip that second one. So this stays the same, so 3 times x minus 1. This becomes x minus 3 quantity squared. Okay, this is going to factor and become on the top. So I'm looking for the factors of 6 that add to give me 5. So that's x minus 2 and x minus 3. And on the top here, I have a common factor of 6 and x minus 1. Now, keep in mind, this is the one that people tend to just miss all the time because it can be 6 and 1. Sometimes it's 6 and 1. Sometimes it's 2 and 3. So just check. Negative 2 times negative 3 is positive 6. Minus 2x minus 3x gives me minus 5x. So I have the factor of x minus 1 on the top and bottom. I have an x minus 3 on the top, and I have 2 on the bottom. And I have a 3 and a 6, and 3 goes into 6 2 times. So sometimes I circle these things because it's hard for you to see them when you start canceling everything. But what we end up with is on top, we have x minus 2, and on bottom, we have 2 times x minus 3. Okay? If you're thinking about canceling, that is a term. It is part of this subtraction problem. So these two things, this is a factor, but that's a term, so they cannot cancel. Okay? Again, what can x not be? Okay, so from the beginning, the bottom of the first one says x can't be 3. And remember, when it's division, you have to look at both of these. So, however, there's no variable here. So this is going to be 1. That's the 3 that I've already said, and that's 2. So basically, we have 3, 1, and 2, 1, 2, and 3. The order that you write them in does not matter. Okay? Again, another division problem. So when I come down here, I'm going to change it to multiplication and flip things. All right, 7. Guys, there's only one way to factor 7, and that is 7 and 1. And if it's minus, one of them has to be negative. So I'm looking for those. How do I get positive 6? As if I have positive 7 and negative 1. On the bottom, same thing with 9. Okay, so really hope, yes, you have 3 and 3, but we also have 9 and 1, and I need the factors that subtract to give me 8. So, again, x minus 1, x plus 9. Over here, this one that's on the bottom is going to be on top, so we'll go ahead and do that. That's x and x. That's a little more challenging. I need the factors of 18 that add to give me 11, 9 and 2. Okay, again, when you're adding, these signs will always be the same, and they'll take the sign of that second term. And the factors of 14 and 1 don't add to 9, but 7 and 2 do. So x plus 7 and x plus 2. So let's see what we got. I got an x minus 1 on the top and the bottom. I have an x plus 9 on the top and the bottom. I have an x plus 7 on the top and the bottom. And I have an x plus 2 on the top and bottom. So I hope you didn't put 0 in that blank, because anything divided by itself is 1. So your answer is 1. And x cannot be 1, negative 9, negative 7, negative 2. I've already said negative 2, and I've already said negative 9. So we got 1, negative 9, negative 7, and negative 2. All right, turn your papers over. And we are still performing the indicated operation. So this time our operation is adding. And to add fractions, I have to have a common denominator. So we're trying to make these two the same. Now, if you factor this, it becomes x plus 3 and x minus 3. And you can see that there's nothing the same with this. So I'm actually going to use, let's see if that thing will go away. I'm going to use, stop it, x squared minus 9. So this factor and those two denominators have nothing in common. So I'm going to have to multiply this one by x squared minus 9 over x squared minus 9. This one I'm going to have to multiply by x plus 4 over x plus 4. So you are multiplying this binomial times a monomial, this binomial times a monomial. So what's that going to give me? And also, what I like to do is when I do this, I go ahead and write them all. I'm going to combine them under the same denominator. So this is going to have, my denominator is going to be x squared minus 9 and x plus 4. So 5x times x is 5x squared. 5x times 4 is 20. I don't like that. Oh, poo. Let's try that. Try that again. Oh, no. Whatever. X squared minus 9, x plus 4, 5x squared plus 20x plus 2x squared minus 18. So I combine my like terms, and it looks like I might run out of room. See if I can move all this up. Oh, look at that. That is not what I want to do. Let's combine like terms. I'm just going to do it with a different color so I can see what I've got. Okay. 5x squared, actually I think it'll fit. Let's put it right here. So that gives me x squared minus 9, x plus 4 over, and that's on the denominator, and on the top, 5 plus 2 is 7x squared, plus 20x minus 18. Now, are there any factors? 7 times 18 to give me 20. I can tell you right now, it's only going to matter if this is one of the factors, which you know is x plus 3 and x minus 3, but it does not factor. And to be perfectly honest with you, I'm not going to give you something that's going to be that hard to factor. So if you see it like that, you'd be pretty free just to leave it. 7x squared plus 20x minus 18 over x squared minus 9, x plus 4. And I've told you, you don't ever need to multiply out your denominator, because you need to keep it in factored form, because it might cancel with something in the numerator down the road. Okay, what does x not equal? That's why you needed to factor this and see it. So x cannot be plus or minus 3, and x cannot be negative 4. So that's what we got. All right, on to the next one. Again, I'm going to factor this bottom to C, and that's going to give me x plus 2 times x minus 2. Now, these two are the same, x plus 2, x plus 2, so this guy needs x plus 2 over x plus 2 so that I can have the same denominator. Okay, so as I have done before, I'm going to write it all over that same denominator, which is x plus 2 times x minus 2. Seriously? Okay. This one I didn't have to do anything. The bottom already is my common denominator, so I'm going to have my 6x. But I do have my negative 3, and we talked about the fact that this has to be distributed. So it's like negative 3 times x, which is minus 3x, and negative 3 times 2 is minus 6. So when I combine those, that's going to give me 3x minus 6 over x plus 2 times x minus 2. Now, that factors. You do have to always think about that. It has a common 3, leaving me with x minus 2, and that is over x plus 2 times x minus 2. And this simplifies. So my answer is going to be 3 over x plus 2. And what can x not be? Plus or minus 2. That's the only thing that we have on the bottom. Okay? All right, moving on to our complex fractions. Please notice that the directions no longer say, and there's not a blank here for your restrictions. Okay? But what we're doing here is we're multiplying by the least common denominator, which y'all are pretty good at figuring that out. However, we're going to talk about it real quick. Excuse me. 3 over x. X is my denominator. 2 over 1. I have a 1. 5 over x. I have an x. 3 over 1. I have a 1. I don't need to worry about the 1s. But these are both x, so that means that my least common denominator in this case is x. Now, you can either do this, and you have to remember to distribute, okay? But in case anybody's still having trouble with that, I want to show you another way, and that is, if you know what the LCD is, just like you have to distribute, go write it next to everything that you have to multiply. And if you have a fraction, then put that x over 1. So it's the same thing that I just wrote, but I'm just showing how I'm already distributing it. And when you do that, okay, those x's cancel, leaving me with 3. 2 times x is 2x. These x's cancel, leaving me with 5. And 3 times x is 3x. So there's nothing you can do to simplify that. So that means that my answer is going to be 3 plus 2x over 5 plus 3x. All right, this one might be a little more challenging, looks a little rougher. However, check yourself. Is x plus 6 times x plus 2 equal to x squared plus 8x plus 12? And it is. And this would be one that I probably would not do it like that because there's more than one term here. So I'm going to do what we talked about, which is multiplying top and bottom by the LCD, which is this times this. Okay, x plus 6 times x plus 2. Now, I just talked about, if I multiply that out, I get this. I did not write that correctly. Oh well. X squared plus 8x plus 12. Okay? So if this top equals this bottom, then this whole thing is equal to 1, which is why I can do this. I can multiply anything by 1 without changing the value. So on the bottom, the reason I wrote it like that, sometimes it's easier for people to figure out those two are going to cancel. So what do I have left on the bottom? Is a 3. Now, my x plus 6 is going to cancel with my x plus 6. So I'm going to have 3x times x plus 2. Plus, my x plus 2 is going to cancel with my x plus 2, leaving me with 6 times x plus 6. And I need to multiply that out. So that's going to give me 3x squared plus 6x plus 6x plus 6, nope, plus 36 all over 3. And when you combine like terms, you're going to get 3x squared plus 12x plus 36 all over 3. And you need to notice that 3 actually goes into each of those numbers. So 3 into 3 is 1x squared. 3 into 12 is 4x. And 36 divided by 3 is 12. So that's what we have. Okay, so the last thing that we got to talk about are the equations. Okay, now pay attention. If you don't have any trouble with equations, you can just check from a certain point. But I'm going to talk about it a little differently because some people are still having trouble. So what I'm going to do is basically I'm going to get the common denominator, the least common denominator, and I'm going to show you how we do that. But after that, then you get to ignore the bottom. And I can't believe I'm actually saying this, but this is going to help some people understand. There's a mathematical reason behind it. If you are unsure, I'll be happy to answer that for you. So, if I'm trying to get the same bottoms, I always have to factor. So this guy has a common factor of x. They both have an x. But y'all have done this before. So if you acted like we were just adding them, then I have to multiply this times it needs an x plus 2. So I multiply the top and bottom by x plus 2. Okay? My bottom, my denominator is x times x plus 2. So I'm going to multiply this one that doesn't have a bottom times x plus 2. X plus 2 times 1, in case you can't see that. Okay? Now, so I got the least common denominator. That's what this is right here. Okay? This is one right here. This is another one, and that's another one. And then you can ignore the bottom and set the tops equal to each other. So that's going to give me x times x plus 2 equals 1 plus x minus 1 times x plus 2. Now, if you did it the way I showed it to you in class, you're going to be at this step. So now we're all on the same page. But some people just have trouble doing the multiplying thing and canceling, and this just kind of makes that easier for them. So, of course, I have to get rid of my parentheses, so that gives me x squared plus 2x equals 1 plus, that's FOIL, first, outside, inside, and last. Okay? I have an x squared on both, so they go away. That gives me 2x. I'm going to clean this side up a little bit. 2x minus x is x. 1 minus 2 is negative 1. So 2x equals x minus 1. If I subtract x from both sides, I get x equals negative 1. Now, we talked about this in class. Remember that you need to check your restrictions. What kind of restrictions do you have? And really what you're most concerned about is if you plug in negative 1, are you going to have a 0 on the bottom? And we are not, so the answer to this problem is x equals negative 1. Okay? And moving on. This one is different from the first one because there's no plus on either side. So this is what I was referring to as a proportion. And the way you solve a proportion most easily is to cross multiply. So that's going to give us 3x minus 5 times x plus 2. And that's equal to 2x times x minus 4. All right, so I'm going to FOIL first terms, 3x squared, outside plus 6x, inside minus 5x, and last minus 10. And that's going to give me 2x squared minus 8x. And I was trying to write squared, and it's not squared. Okay. I have a squared, and they're not going to cancel. So if they're not going to cancel, then I need to bring them both to the same side. So I'm going to take both of these over here, which means I'm going to subtract 2x squared. 3x squared minus 2x squared is x squared. 6x minus 5x is x, but I get to add an 8x to it. So that makes it x plus 8x is 9x. And then I have my minus 10. Okay? Does it factor? Well, I hope y'all are saying yes, because there are factors of 10 that subtract to give me 9. And that would be 10 and 1. 10 times 1. So some people tend to put a 9 there, y'all. 10 times 1 is 10. Now, one of these has to be different. If I need a positive 9, I need a positive 10. So, set each factor equal to 0, x equals negative 10 and positive 1. Does that make the bottom 0 in either of those cases? And it does not, so x equals negative 10 or 1. Okay, last one. Let's go here. And we're going to do the same thing. I'm going to do it like I just did number 12. I'm going to factor x minus 3, x plus 3. So that's actually how this factors. X minus 3, x plus 3. Go away. Why won't it go away? All right. Now, I want them to look like, so y'all already know this. You know, to make it look like this, because I see both of these in here. So this one needs x plus 3 over x plus 3. This one needs x minus 3 over x minus 3. And this one doesn't need anything. So what do I have on top is 3x times x plus 3 plus 1 times x minus 3 equals negative 6. Then it didn't have to get multiplied by anything. So I'm going to distribute to get rid of my parentheses. 3x squared plus 9x plus x minus 3 equals negative 6. I'm going to clean that up. It's squared, so I need to bring it all to one side. So 3x squared 9 plus 1 is 10. And if I add 6 to both sides, that's going to give me plus 3. Okay. Again, not necessarily hard to factor, but I'm looking, I got to multiply a times c. Okay, and a times c is 9. Are there any factors of 9 that add up to 10? There are, and that is 9 and 1. So, and just to refresh some people, if you know this, okay, if I know the factors are 9 and 1, then what I've talked about when I taught you was that you would divide both sides by 3, both of those factors by 3, and simplify where you can. So in the denominator is what is going to be the coefficient. So that means my factor is x plus 3 and then 3x plus 1. If you want to know more about that, come see me in the morning or during the AO. Okay, but I'm going to check it. X times 3x is 3x squared. 3 times 1 is 3. And there's my 9x and there's my 1x. Okay, so I'm going to set each of those factors equal to 0. So that's going to give me x equals, I'll put it down here, my honor statement. X equals negative 3, negative 1/3. And if you notice, I can't have negative 3. Back up here at the top, negative 3 is going to make this thing 0. And so I have to cross that out. And the only answer I have is x equals negative 1/3. So I hope that helped. If you have any questions, email me, come see me in AO, or come see me before school. And of course, the wonderful IXL has lots of examples for you to do also to practice. Thank you very much.